Please make sure you have your copy of the assessment on calorimetry. What I want to show you is how I collected the data for problem 4, the mass of a scoop of ice cream. Our goal is to find out how much does a scoop of ice cream weigh, not by weighing it directly on the balance, but by using calorimetry and heat exchange measurements. So when we did this in class, we went from station to station and we followed steps to collect data. I'm going to show you how I collected the data when I did the experiment. So you can use my data. And then when you get these data, you'll need to use them to fill in the data diagram and then use the data from the data diagram to perform the calculations. So the first step, I cleaned up my hands and then I got an empty cup and I put it on the balance to weigh the empty cup. So for step 2, where it says mass of empty cup, you should write down 2.38 grams. Then I put some water in the cup, hot water, about half full, and some scoops of cocoa. This is with marshmallows. So a couple of those, that should be sufficient. And then we mixed it around using a thermometer, and we measured the starting temperature of the cocoa. So I'm mixing this around, and then when I'm done mixing it, I'll show you what the starting temperature for step number 4 is. So step number 4 says that the cocoa is 78 degrees Celsius, so it's pretty hot cocoa. And then we put the cup on the balance to weigh it, to find out how much does the cocoa weigh with the cup. It's 139.94, so you should record that for step 5. 139.91. 88. Well, it's evaporating the water as it's sitting there all hot. Well, let's pick a number and write that down. Pick any of these numbers, it'll be just fine. The steam coming off is causing it to lose mass. So what the mass is whichever one of these numbers you choose, and that'll be fine. Okay, so then what we did was we took a scoop of ice cream. This is the good part. Let me put that down and get myself a scoop. Okay, so when I put the ice cream in, it's going to exchange heat with the hot cocoa, and the cocoa is going to cool off and the ice cream is going to warm up. So I'm going to mix this around until it's done changing temperature. I'm watching the temperature to see when it's all done melting. Now this could take a little while, so you might want to fast forward through this until we get to the ending part while I'm mixing this around. While I'm doing this, let me just make sure that you see an important piece of information. You know the mass of the empty cup. You also know the mass of the cup containing the cocoa. One of the things that you'll need to do on the data diagram is fill in what is the mass of the cocoa. Okay, so that's not the mass of the cup. It's not the mass of the cup plus the cocoa. It's the mass of just the cocoa. I'm just putting that out there as a suggestion, something to think about, something to remember. There's a step that you need to do there. I didn't put a line for that step. I'm just kind of expecting people to know what to do with that, so use your best science thinking skills there. Now this ice cream is just about done melting, and the temperature of my cocoa is just about done going down. So let me mix that all around there. And again, you can fast forward to the end if you're not patient. Sorry that you're not here to enjoy this. Okay, let's see what we've got. So the ending temperature looks like it's 45 degrees Celsius. So it went from that initial high temperature down to 45 degrees Celsius. The ice cream scoop warmed up from 0, which is the frozen temperature, things freeze at 0 degrees, and it went up to 45 degrees. So that's the ending temperature for both the ice cream and the cocoa. Everything ends at the same temperature in the calorimeter. So now you should have all the data that you need to fill in the data diagram. There's some calculations you'll need to do to find out what's the temperature change in the ice cream and the temperature change in the cocoa when the cocoa cooled and the ice cream warmed up. And then use those data to do the calculation. And make sure when you do the two calculations that for each one you use the data that's appropriate for the calculation. The first one is about the cocoa. so make sure you're using data about the cocoa. The second one is about the ice cream, so make sure that you're using data about the ice cream. In between the two calculations, there's only one heat, so make sure that you use that one heat for both calculations. And good luck!